welcome to Unapologetically Technical. My name is Jesse Anderson, and this is the show that's different. We go deep, we go all the way down. With me today is Jacopo Tagliabue. He is the founder at Bauplan. Welcome to the show, Jacopo. Would you mind introducing yourself a little bit more?
Yes, thanks so much, Jesse, of course, for having me. Thanks, everybody, for listening in. I'm originally Italian, but I've been living in the United States for quite a while. My normal, I call home New York these days, even if I'm in California a lot because of, as you can imagine, company building and so on. While today I'm actually in Italy, but in a completely different part from where I'm born. I got a PhD a long time ago in a completely irrelevant field. And I've been doing, a bunch of computer adventures for the last 10 years. This is my second company. My first one was called Kuzu. I guess we're going to talk about that a bit. And I'm very passionate about any topic in the intersection of computers, data, AI, language, and so on.
Well, good. Well, welcome to the show. And as you mentioned, you're in Italy. So you're in Puglia. For people who don't know where that is, that's in the heel of Italy. It's all the way at the bottom.
Correct.
And I didn't realize that I really want to go there. Oddly enough, I tell that to everybody. I want to go. I love traveling. And I didn't realize how much the cuisine was different, not just in various parts of Italy, but even in Bari, as opposed to Naples, as opposed to Roma. Tell me more about that.
I think one thing that people first come and visit. We have a very large house that is meant to be shared with friends. Second, I think many people don't realize how diverse Italy is because it's such a tiny country. Like Italy is approximately half the size of Texas, just to give the audience like a point of reference. And with this tiny part of land, there are hundreds of dialects and languages. And many more cuisine variation you can count or you can ever experience in your lifetime. So Puglia is very different from the region nearby, even if they're like 100 kilometers far from there. And even in Puglia or in different other parts of Italy, you will find regional variation within these regions. This is especially true for very specific things like wine. So if you're a wine expert or just a wine aficionados, you will know that the same region like Piemonte will have very different wines, even like 50 kilometers one from each other. And Italy is like that at a fractal level. So differences are like between neighboring villages, between neighboring regions, between neighboring parts of the country, and you can find all these stratified differences because of the more than thousands year history of most of these places. Like in the city that I'm in, the first archaeological artifact that we have is from the Neolithic, and the castle that is on the hill next to, like just behind me, like you can see it, but just behind me, is from the 12th century. And so so that's kind of like the type of stratification of tastes and usage of prime, on veggies and beef and whatever you want that has been stratified in the course of literally hundreds of years. So yeah.
And then, would you mind showing the audience too your roof, your vaulted roof? Because
sure. I'm just going to do a bit of this. So this is our office. So it's not the biggest room, but like the vaulted ceilings are very tall, which is a very Puglia thing. Like if you come to Puglia, you will find in most houses that have been built 100 years ago, like between 100 and 150 years ago, have this style. So if you're lucky enough to find a place that has been restored, but keeping the original kind of vibe, that's the type of architecture you're looking at. It's very bad for air conditioning in general, energy saving, but it's very pleasing on the eye and kind of gives you this, very good sense of space of like, being in kind of this, tiny part in this much larger history that unfolded before you, and I'm sure will unfold after me.
Well, just to give an example, even the pizza differences between Puglia and Roma or Naples, Napolitano style pizza. For example, Puglia has mortadella and pistachio pizza. Which,
yes.
If the people watching this have never tried, try it once. If you like mortadella, it's amazing.
It's very good. It's very good. I'm a personal favorite. Like my personal favorite is like the Napolitan kind of like very thin pizza. If I have to pick, I eat everything that's called pizza for the same reason that I drink everything that is called coffee. I don't make much attention about it, but then I have my favorites within this category. So my favorite coffee is espresso, but I will totally get a Starbucks one if that's around. I'm not gonna complain. And my favorite pizza is Neapolitan, thin pizza. That's my favorite. But I will totally get a thick pizza in Chicago if I have to, and I'll still be happy. I'm a very, again, in that sense, I'm kind of a crossover between. I mean, at my age now, I'm a crossover between Italians and American tastes in some sense. So that makes me, weird in both countries. Like American things that I'm too sophisticated, and Italian things that I'm really not enough sophisticated anymore. So yeah.
Well, then, which is your favorite pizza? Is it the
My favorite
margarita?
pizza is my favorite pizza is the one like is margarita, but is topped with spicy salami. It's typically called diavola, which means the pizza of the devil, if you translate, because I like the combination of the mild margarita, say, base, and this kind of cured spicy salami on top to give a bit of a kick.
And for the Americans or people who aren't familiar with the diavola and pepperoni, sometimes people will say they're the same, but they're not. They're pepperoni is a different spice, different taste. Diavola is probably the closest. I love my diavola, but I still love my pepperoni. I like the taste of that pepperoni. That fennel is just too tasty.
Yes, yes, that's a very good point. Like there's isomorphism, you would say, between different pizza in different parts of the world, but then there are these slight differences that will actually at the end of the day build this incredible combinatorial space of tastes in that sense. So if you like that type of exploration, which is not the search space that we the query engine do, but is the search space of your taste. Italy is one of probably the most beautiful country, because in such a tiny space and such a small amount of time, you can literally explore this space in many different directions, as people are very proud of their local produce. So again, something that outside of Italy, maybe Japan is the same, maybe France is the same, but it's definitely not the standard in North America. But in Italy, people are very, very proud of things. They grow only within 30 kilometers from when they're born. And so they will do a lot of bragging, but also a lot of invention that is basically specific on something you can always find there, which, it has its pros and cons. But as you said, for a vacation, for a trip, it makes for a lot of adventures in the culinary world, if you will.
It is. And I really want to do a train tour of just going up and down Italy. And as you were talking about, I was thinking about historically, Italy wasn't Italy until the 1800s, late 1800s. It was separate. So, and then that separation also brings a separation of it culinarily, where you have Venice being very different culinarily from these other places, the Papal States. You had it's super interesting how food relates with history, which relates with culture.
Yeah, Italy is a much in the sense of modern state, of what we consider a modern state, in the 19th century doctrine. Italy is a younger state than the United States. Italy, as we know it today, was 1861, so it's almost 100 years after the United States, even if the country has been, somewhat civilized for thousands of years. And sometimes this gets to the extreme that Italians, villages really distrust each other to these days. Like it's especially older people. And there's maybe we're gonna cut this afterwards because it's too long. But one thing that I always remember fondly about my grandma is that when I was going to middle school, I came home the first day and say, "Hey, I made a new friend." I come from a very, very tiny village in North, and then she asked me, "Where is your friend from?" And it's like, "Oh, he's from the village next to ours." Next 2 hours means literally they're adjacent. Like if there's no sign, you wouldn't even know it's a different village. And my grandma said, people from that village are dumb. I'm like, there are literally 300 meters away from me. Like there's literally no possible difference that, they will support any, blind taste, any A/B test that will fail, because these people are literally the same people with an imaginary line that, that kind of tells you when the village ends. But it was like, that's a type of ingrained distrust that Italians have, for their fellow neighbors. And you can scale this up to the entire country. So I always think this is like an aleph, like a tiny story that tells you a bit more than what it should.
That is funny. Um, I've only heard the stories about Italian nonas and their awesome cooking, but I've never heard them tell your friends are dumb.
Yeah, because of the like the friends that because of course people that lives in that village are dumb. They're like, what's that? That doesn't mean yeah, whatever. But like again, this is in not this extreme form, but you will find him in you like cuisine, so you will find if you go to Emilia, which is where Bologna is, so it's kind of in between. For example, you find that people do a lot of different type of pasta or sauces or whatever. They are honestly kind of indistinguishable from each other unless you have an incredible resolution, but they will be very proud of like, no, this is not like the thing that they do 3 villages next to us. This is our thing. But like, this is really ingrained in highlighting the differences. What I'm trying to say is that highlighting the difference is a really ingrained thing in the culture, especially in the older generations, which is a different, I think, general country ethos than other country. Like, the United States, in many cases, in my experience, like people really highlight and shines on the commonalities, like, maybe not very recently, but like historically, it's like, you feel part of a bigger entity, so to speak. Italians tend to feel that, they're kind of like inside very, very tiny villages, still up to these days, hundreds of years after the Middle Age. And they're sort of proud in that. They're proud of their differences in a sense, which is, again, it's a mixed feeling. But if you know the language a bit and you spend time, you will really feel it, even as a foreigner, like how much people are really protective of their roots and their kind of like local environment in a sense.
As you're talking about that, I'm thinking technically we do the same thing. We have these, oh, one company does it this way, and we do this slightly different. But that slight difference, oh, that makes all the difference in the world. And you're like, well, maybe that doesn't make a huge difference. Maybe it's not as big of a difference. But yes, we have to have that slight difference in order for us to say, yeah, we're better. We are better.
Yeah. Yeah. So give me how many times?
Okay. So you did your PhD, you mentioned. What did you do your PhD in?
So my PhD was in cognitive sciences. So my educational history is a bit all over the place. So it's not, I usually say don't try this at home. But allow me to learn like quite a learn and perhaps master quite a few different topics that turned out to be useful later on for completely unintended reasons. My bachelor was in philosophy because I was really passionate about logic. You can go into that. And then I became interested in more the cognition aspect of it. So AI, cognitive sciences, psychology, a bit quantitative sciences, and so on. And so my final PhD project at the end was a weird combination between formal logic and a bit of theoretical computer science. So also my PhD was spent between logic people and computer science people. And by the end of it, I already decided I didn't want to pursue that. I didn't want to become a mediocre academic, which I think I became anyway. I teach one course at NYU, and I publish still quite a lot, but I kind of didn't want to do that as my main profession. And I really wanted to be part of the industry and make an impact in a different way. But I'm happy about what I learned, and I met incredible people. There are still friends after all these years, and I learned so many things that I can apply to the world of databases, if needed to be.
Okay. All over the place then. So in fact, your resume is initially all over the place too. You worked your first job was at a place called Pallacanestro Olympia Milano, and there you were doing data science on basketball. What were you doing there?
Yeah, so like quite a few years before Brad Pitt in Moneyball, I worked with the professional basketball team in Milan, which is after Real Madrid is one of the most historical basketball teams in Europe. So remember, this is like 2008. Like there's no data science frenzy. I didn't know any Python back then. It's like very, very early days of what people consider quantitative sports, which is now is like a trivial thing. And so I came up with this idea of using what I knew at the time about statistics, which is very little what I know now. But, youth, my optimism, has always been boundless, to try to understand better what people in basketball do. I grew up playing basketball, so it turns out that I actually know quite a lot about basketball. So I'm not like a nerd you need to explain the sport with. I played basketball my entire life. I know exactly what's going on, and so I immediately bonded with what was the how do you say that in English? The not the main coach, but the assistant coach of
Assistant coach,
the assistant coach of Milano, which knew basketball, of course, better than I did, and had a bit of a knack for numbers and for quantitative understanding. And then when I met him, I find out that he was manually annotating on Excel a bunch of things that happened during a game, and that was basically summing stuff up in different categories to get a first understanding of what people were doing. And when I immediately saw that, it's like, wait, I can do much better than this. And so we kind of begin this collaboration in which, by the end of the season, we have this first in your, like, one very, very first attempt to have a software that actually is built for analyzing and producing insight, doing data science, if you will, over professional basketball people, where tens of millions of dollars are on the line. And so that was my tiny contribution to the sport that I loved. I mean, I wish I could have become a basketball player, of course, a much better career than a tech person, but it was not meant to be. But I'm still very happy that I was I played this very tiny part in my favorite sport. And it was a very fun thing. Everything by my standard today was terrible. The software was terrible. My statistic was terrible. The UI was terrible. Everything was bad, and I'm embarrassed about it if I think about it. But it was really, really kind of new, and I was very lucky to find somebody on the other side of the fence that understood this. It's very hard to find a basketball person that understands numbers enough to trust you with that. And I'm sure, Jess, you're seeing with many people in this podcast, we're very good at technical stuff, but sometimes it's hard to cross the edge, the boundary to non-technical people. And it's priceless when you find a non-technical person that still understand enough and trust you enough to let you do your technical magic. And that was a very fortunate event in that sense.
It is. It seemed like you learned some pretty early important lessons. Like, if you have analysis and you don't have buy-in from, in this case, your assistant coach, you can do everything you want, and they'll just look at it and say, "Okay, great, thanks." There has to be that level of buy-in. Or you also used an interesting term a few minutes ago about this endless optimism, or this boundless optimism, I think was what you said. And I see that. I see that there's this optimism of, okay, let's try this. Let's try the statistics. I don't know the statistics completely, but I know the sport. I can apply it. It's interesting lessons early on.
Yeah, it was a fun thing to do as a kid. And yeah, like, it's like I felt it was, by that time I was stopping playing basketball, so I felt it was kind of a good sunsetting of my of my passion. Like, yeah, that's the last thing I need to do, because in basketball I did everything. I played, I coached, I refereed. I did almost everything. I of course I was a fan. So the last thing that I'm missing was, like, can I work for a bit for with a professional basketball team? And so I felt it was a good kind of like sunsetting of my early career.
I can see that. From there, you went to Clear Channel Outdoor. That's an advertisement company, billboards and such.
Yeah, there was like, there was like a collaboration, was a full-time employment. I was a collaboration with them because Clear Channel, which is an advertising company, fun fact, are the ones that handles most bike sharing systems in Europe, or at least that was true in 2009, whatever that is. And the one in Milan, so what they did was basically they took over the Milan bike sharing and starting having these bikes going around. Again, very early days, data scientist, not the sexiest job in the world yet, whatever. And so what I did, again, optimism, I literally cold email the info at bike sharing Milan and say, hey, I'm this guy. I know a bit of coding and I know a bit of stats, and I'm really interested in analyzing your data. And by a random chance, I found somebody on the other side, which is as optimistic as I am, that says, you know what? This is not a bad idea. So it took a while to get, the data clean, anonymized, and all of that. But we were the first team to analyze probably bike sharing data in the entire world, and we published all of our findings in a fun press release conference at the municipality in Milan. And so we built this visualization that helped people understanding how people use bike sharing. So there was not much statistics in the end. It was most data analysis, not a visualization. And it was, again, the combination of, like, the courage to try something, and again, to send an email out in the blue. But on the other side, to find this unlikely person to exist, the guy that works in these advertising companies, the manager of this bike sharing system, that instead of saying the normal thing, no, the fuck is this Jacopo? He said, you know what? Let's meet for a coffee. Let's see what this guy actually can do. And then it turns out to be like an incredible thing. I think the thing that people liked the most was we calculated how many panettones people can eat and then burn by using bike sharing, every day, and people really, really find it very funny. And for me, it was the chance to try to bite some technologies like processing, which is a framework for data visualization built on Java, to do almost real-time visualization, which was very cool at the time. And again, it was a skill that I'm happy that I perfected at some point in time.
And for people who don't know what a panettone is, it's the Italian bread with chocolate in it, if I remember right.
Yeah, is the typical Milan Christmas dessert, which is it's like soft inside. It's not the same let's say that technique of bread, but it's soft inside like it was a bread, and inside he has how do you say that? Fruits. They're the original one is the. How do you say that? You know what I mean? Not smoked, but how do you say that?
Dried. It's a dried.
Yeah, therefore, exactly into that.
It's like
it's very buttery.
Cake.
Exactly, and it's very buttery. So it looks like bread from the outside, but when you actually look at it, it's actually a very dessert type of thing. And you eat it with mascarpone, which is kind of like something that you dip into to make it less dry. But it's a very Milanese. The most Milanese thing that has ever existed is panettone, probably. It's a fun thing, but lesson learned: the value of information and the value of data is half what you actually can get out of your data analysis, statistics, whatever, and half is the storytelling. People will have not guessed the importance of bike sharing in Milan if I present the same information with calories or with kilometers. You know what I mean? But if you say, hey, people in Milan burn, I don't remember, 3,000 panettone a day because of this, everybody's like, that's a lot of burning calories because everybody knows that. So as stupid as it is, I'm sure that that drove the point home way better than any fancy regression I could have done at the time.
Oh, it's completely right. Unless we make it relatable, then nobody's going to really act on it.
Yeah.
It's exactly. From there, you went to Diagramma, and you started doing NLP. And it's been kind of interesting as technology changes, where now everybody, I think when we first met, we talked about this. Now everybody's doing NLP. They don't call it NLP, they call it LLMs, but now NLP back at that time was a pretty fringe thing. What got you into it?
Everybody now is doing NLP without knowing NLP, which is the fun bit. Back in the days, NLP was mostly a combination of statistical technique and symbolic technique that were applied to very specific language problems. This whole thing that now you have one model that does everything in language is a very recent thing. It didn't exist until 3 years ago, or whatever that is. When I was a kid, you have NLP special models or special system, which is a combination of models and rules that will tackle specific problems. Like a problem that I tackled early on, which is was I was working at the time in Diagramma, is part of speech tagging. Part of speech tagging, which was, let's remember, an unsolved problem just a few years ago, is this problem. When I say the sentence, I enjoy the play, what are the part of speech that compose this? I is a pronoun, enjoy is a verb, D is a determiner, and play is an ambiguous word. Play may be a verb, or maybe in this case a noun. And so a part of a part of speech tagger will be able to identify the play in this case is a noun. And that's a combination of technique. I mean, at that time, it was a combination of hidden Markov models and a bit of rule for handling some edge cases and so on, which I think it was the state of the art for most people. Right now, all of this is done internally in some neurons. Like all of this is done automatically to you in some millions of neurons you're never gonna see or understand inside of billions of neurons that compose like a large neural network. The interest in language was both because I wanted to do something that has like that is applied, but as a deep tech component. Like NLP was a really hard problem back then, and to some extent is now, even if the challenges are different. Like NLP is like a quintessential AI problem. In fact, Alan Turing, when people need to decide what constitutes the proof of intelligence, language is the first thing that always comes out. Turing test as an example, right? When Turing said, how do we know if you're intelligent? Well, we just chat. Okay. And so chat is sort of this kind of like mirror into the underlying cognitive system. So that's one part of it. That's why I was drawn to it. And the second part is because NLP, historically, this is not true anymore, has a lot of connection with logic, which is the topic that I was drawn into in high school when I read a book called Gödel, Escher and Bach, which is a fantastic book about Gödel theorem and AI and a lot of stuff, which got me into logic and philosophy in the first place. So I've always been passionate about languages and the structure of languages. And the structure of formal language, like first order logic, it turns out to be similar to some part of English, for some definition of some. And so it was kind of like a natural continuation of things that I already knew how to do. I don't know if that makes sense.
It makes sense. And I forgot to define what NLP was. That's natural language processing. This is what we had to do in order to break down sentences. You had things like lemmatization and stemming, and as you mentioned, it was pretty much, there were some models to it, but it was a lot of models plus rules, and those rules would always break down. That was your problem.
Yeah.
And when people don't understand what the breakthrough of LLM was, they kind of understand it now, but they don't understand that breakthrough was the ability to do all this without rules.
Yes, and to do all of this level. So instead of having 4 systems to divide words into parts, understand this part of speech, and then understand the syntax, and then understand semantics. So all these systems are brittle and combined together, they're compounding their brittleness. LLMs somehow do this all in one pass, so to speak, making the inference much more robust and being able to do that. I still not sure what is the final lesson is for people that study language as an object, like I did for many years. But it's a definitely different perspective in this. From the applied perspective, from the person that needs to apply the NLP and doesn't really care about what does this say about language as a object of study, LLM has been the biggest revolution that I've seen in my life. Most of my NLP friends, and to me to some extent, right now we go back to our PhD, which wasn't 3,000 years ago, it was like 15 years ago, whatever, and we say our PhD dissertation is now a prompt. Which is true. Most of the NLP people I know, like they are being out-prompted in their entire life study because of LLMs, which is a testament to how big this revolution is for people that haven't worked in NLP for years. So maybe they just see LLM and they don't remember what it was before, but I remember what it was before. Again, then there's a deeper question for nerds about what does this say about language? What about all the things we know about language that linguistics tells you, that logic tells you, and all of that? What is the role of that in this new world? And I think that's an open question for scientists in that sense, but perhaps not an important one for engineers building systems.
Yes. Well, perhaps the bigger question was, you went into project management. Why did you go into project management at that point?
So that's a very good question. A bit of context on how Italian, companies tech usually work. So Italy is a country, generally speaking, of many, many, many tiny companies for historical reasons. So Italy is very small, have a lot of very small businesses, you call SMBs in the United States, and there's a few very, very large companies in tech. But A, they're not as large as Facebook or Google or whatever, and B, they're not that many. Companies with more than 1,000 people doing tech stuff in Italy are probably a handful. Okay, so if you work for a smaller company, even a very innovative one like the one that I was working on, at some point it's sort of normal to be managing project and not just doing IC work, because there's not enough, there's not enough interesting or deep or enough system that you need to build as an IC. So if you want, in some sense, to learn new things and upskill yourself, the natural way to go is up. Because by going up, you make the connection between the business problems that we're solving at the end of the day, always, and the actual tech. Because after a while, the tech shows diminishing returns in a way that doesn't make sense for you to become, a tiny bit better in NLP. So there was kind of the natural choice of like, okay, I know enough about NLP to build a system that sort of works and does what we want. How do we connect this to our clients? How do we manage people? How do we discuss basic stuff like, account payment schedule, like a lot of things that I actually used 5 years later as an entrepreneur. I learned them by transitioning into project management and product for a bit. On the minus side, it's not the most exciting job. So on the minus side, I still prefer, at that point, it's a job involving a lot of compromises, a lot of scheduling, a lot of timelines. Like you feel you spend most of your days keeping track of work instead of doing the work, which I understand why it's necessary. But if you talk to me, that's less, I would say, fulfilling than other parts of the job in a sense. Ironically, now as a CTO of a small company with a very, very competent tech team, but small resources, mighty team, a lot of ownership for everybody, I became sort of a product person again. As I code way less than what I used to, and most of my job is to make sure that people don't do stuff. They're better than me at single stuff. That's why I hired them, right? So that's but my job as an entrepreneur and CTO is making sure they don't go down the wrong rabbit hole or they don't lose sight of the forest for the trees. And that's a skill that I perfected doing management early on in my career, I have to say.
You're a cat herder now.
Yes. Now I do things that nobody else wants to do. I do test. I do documentation. I do reference implement. I fix bugs now.
You've been promoted to CTO, and you get to do all of the things that a junior person does.
Exactly. Now that I'm in charge, I can finally do all the things that nobody else wants to do. And actually, I don't want to do either. But that's my job as an entrepreneur is get done for the company and the shareholders, not to complain. And if the people that I hire, I'm happy to do other stuff, and they are higher leverage in other stuff, there are things that are qualified to do. That's what they should do. The random stuff that Jacopo can pick up between a podcast and a phone call, Jacopo can do that, and it's fine for the company. I find that at this stage, my highest leverage, my biggest marginal value in the company is my generality. Is the fact that I can fix a SQL query in the morning, talk to a venture capitalist in the afternoon, and design, write a paper about systems and design the architecture of the system all in one day, to a level of satisfaction that is, good enough for all of this persona. And then the details somebody else can is better and can be empowered to do that.
You bring up something that I've been thinking a lot about, and that is this level of cross training that you have to do either before or during while you're being an entrepreneur, I think is unique. It doesn't put you into this nice little niche that companies like. They like a person with this job title, with this function, here are the things. And then as you cross train, that becomes more and more interesting to be able to, oh yeah, I like to be over here sometimes and over here. And then you never fit into this nice little box anymore. What do you do then?
Yeah, I'm unemployable by now. As in, I either employ myself or it's very hard for me to find. Exactly. It's very hard to find a job description that says, a bit of NLP, but also how databases work, and how to talk to an enterprise customer and raise millions of dollars. There's not a job description that fit that, and so the only way to do that is creating your own job, which, to be fair, is one of the best thing of being an entrepreneur. I joked before about not wanting to be a mediocre academic, which again, it turns out to be that I probably become one, unwillingly. But one of the problems of academia is that academia actually really like people that do exactly the thing you described. They are really deep in one thing, they do one thing well, and they just do the entire career on that. I am the exact opposite of this. I get bored every couple of years of a field. I need to change field. I love to go, from one field to another, to cross-pollinate these fields, which I think is like one of the highest level of skill that I have. And being an entrepreneur allows you to do that. It comes with a lot of responsibility and a lot of tasks that I need to do. But on the other side, it gives me this flexibility of moving vertically in the stack. I can do a design doc, but I can also again open the laptop and actually do fix a bug, and horizontally across the full product cycle, which I really love. Talking to the customer, working backwards to what is a product design that makes sense, then the API, and then the technology, and then going back to measure the customer value. And the entrepreneurship is the only route that allows you, that I know of, that allows you to do all of this well. So yeah.
Yeah, that would be the piece of advice I would give people who are thinking about starting a business or doing a startup. It's exactly that. It's not just that ability, but it's also, I would say, a desire. Perhaps a desire on one side where it's not pulling teeth on the other, somewhere in that middle thing, because you will inevitably be this person who does this and does this and does this. Where if you're coming from a big company, somebody else did that and somebody else did that. No, you look to the side, you look to your left and right, and there's nobody else doing it. So
Yeah.
It either doesn't get done or you get it done. And that's a very different thing, that as an entrepreneur, you just have to be ready to do that.
Yeah. And you need to, so there's no such a concept of is another team's job. There's one team, it's everybody's job to get it done. And again, at the end of the day, the bucket stops with you. If you're the founder, you're the person responsible for, in front of your investors and, your shareholders about, what the company is doing. And there's a willingness to go out of your comfort zone. Both technically, I didn't know much about databases before 2 years ago when I started this company. I didn't know anything of information retrieval before I started my previous one. So there's a willingness to go outside of your comfort zone and feel stupid for quite a few months. And then there's the ability on the other side to pick up fields, entire part of computer science, of technology, or things like to pick up fields very quickly, like to be able to get to, advanced underground level in a few months. And so the combination of these two things makes, to me, a very powerful technical founder, because there's no challenge you cannot solve to some extent. And you always have the ability to move across different layer of the product in some sense. But it's a lot of work. Like it's really a lot of willingness to do it is always the first kind of characteristic that you need to have.
Let's talk more about your careers. The next company that you went to was Axon 5.
Yeah.
And it looks like at that point you moved to New York City. Is that correct?
That is correct. So I moved back. So during my PhD, so I've been to the US as a student a few times during my life. So I spent like some time at NYU when I was a kid, because it was a good thing to say to your parents. Like if you say, I'm going to go to New York for a few months, and they're going to say, what the thing. But if you say, I'm going to take classes and learn more statistics, and it just so happens to be New York, they're going to say, okay, yes, it's fine, go. And so it was a fantastic, I spent a few fantastic months in my youth in the Lower East Side that cemented my love for New York, which will turn out to be useful in this story. Then I spent some time at the Santa Fe Institute, which made a lifelong impression and lasting sort of impact on the way in which I approach science, complexity, generalism, and all of that. I love the place. Santa Fe is an amazing place. If you guys don't know it, go check it out. Some of the best person and most intelligent person on the planet go through that. Not me, but like others. And then during my PhD, I was part between Milan and Boston. And so I came back after a PhD, and then a person that I met in Boston, his name is Thomas, was saying, hey, I'm building this data science office in New York, and I want somebody that has already has industry experience to lead it. Would you be interested to do that? And, I remember my summer in New York. It was amazing. I always love New York. And I'm like, yes, I was already thinking of moving. Can you move me to New York? And they're like, yes, come and build the office with me. And that was the moment in which data scientist was the sexiest job on the planet. It was like 2016, right? The explosion of the first wave of data scientists, which was mostly, we don't have tools, we don't have practices, but there's a bunch of people with a PhD that are obviously able to figure out complex stuff. You go and do complex stuff. And that was data scientists, those magical, no ROI, no questions asked years. But it was fun. It was fun. I've some of my best friends still today in New York are from Axon. And Axon was an incredible company to do cutting edge things. and learn how a startup was actually built. The company was not small compared to my comp, like compared to Tuzo, but it was still like 50 people, so very manageable size. And I was close to the management. I was part of the management team in the company, so I was also got a bit of exposure to the world of like, funding, how you run a startup versus a traditional company, what design a product from the ground up means, and so on, which again turns out to be super useful for my entrepreneur experience. But the thing that I cherish the most about my Axon time is the people that I met. Our Axon team in New York, for completely random reason, was absolutely incredible. Everybody there was not just super nice, but was like supremely competent. And I made like lifelong friends, in those few years. So I'm super happy about that.
That sounds like you had a great time. So you called yourself a generalist data scientist while you were there. Do you think you can still be a generalist in data science, or do you think you need to specialize?
I don't know. I think data science as we know it, those back days, that doesn't really exist anymore. I think the person that does data science, as in there's some data there, go analyze it and produce some ad hoc analysis or visualization or whatever, help us doing decisions. That is not true anymore in most normal companies. If you go big enough at Facebook, there's going to be value in having people doing that because, again, marginal increase in the amount of time you click on something will be billions of dollars at that scale. But most normal company, I think, have been transitioning from the notebook data science that sits there and do magic, but unclear what, to a person that actually is part of a product, understand the product, write decent code that goes into production. This is a huge problem we're trying to solve with Bauplan as well. But I think there's a genuine willingness to put data science as part of your normal software org and not being these people on an island doing data science stuff. So the short answer is, I think it will be very rare and a unique position to be what I used to be, a generalist data scientist. But it's not impossible if you go big enough or weird enough in some sense. To be fair, I have no desire to become that again. I'm now doing way more software than data science, and I find it more fulfilling in many aspects of it. So it's not that I miss the old days, but those were fun old days because the field was there for us to mold. There was no a million tutorials on Tour data science or Medium on how to do. Everything needs to be literally invented as you were doing things, which is a fun, it's a fun place to be. When a field is born, it's a fun place to be because a lot of low-hanging fruits, a lot of things are there for you to just pick up, which is very different than coming to a mature field where you feel that everything important has already been said.
So you led the data science there. What do you think leading a data science team means?
So at that time, I confidently can say that because I think now I'm in a better position than I was there. At the time, I didn't really know what I was doing. In the sense that data science was so new that even how do you manage a data science project was a completely unknown factor. Right? There were people that were saying you should do agile, like you do with software. So you just embed these people in the normal software process and whatever. And then there's people saying, you know what? Cannot do agile because if you think about data science as exploring this unbounded list of questions, because a question will lead to an answer, which will lead to more questions and so on. You can't really box this in 2 weeks. You know what I mean? I can't tell you Monday what is going to be done by Friday. That depends, meaningful sense, but what the data will tell me and whatever. And so it was a very tricky thing to balance the need for predictability from the point of view of somebody building a product, building a company, building a fundraising strategy, the CEO, again, us as part of the management team, and then the guys on the ground in the team actually solving incredibly complex problem. It was geolocation problem mostly at that time, incredibly complex problem with no guidance or again no best practices, no things you can download from the internet and say, oh, this just works. So it was very challenging. Perhaps I didn't do the, in Insight, I didn't do, the best of this trade-off in a sense. But we also achieved quite a few cool things for such a small companies. And I learned about things about what not to do when it turns out to be my time to call the shots, entirely. and to manage people doing research. A huge part of Tuzo, Coveo, and definitely Bauplan is our ability or willingness to go and do very, very hard research problem by collaborating with academia. And we can talk about why we do that and how we do that successfully. But the way in which I now manage my academic counterparts and my interns and my researchers takes is better now because of the errors and mistakes and all the process we went through in 2016 with my previous team. So I'm thankful for them to not quitting on me at that time and to be still friends, very good friends at this time. But it was a learning experience, I guess, for everybody, and everybody went on and have a fantastic career. Everybody on the team went on and have like a fantastic careers. Which was very clear at the time that everybody was stellar.
It's interesting you talk about something as fundamental as which methodologies, agile versus this. Paco Nathan, I don't know if you know Paco Nathan, and my work was the very first work and actually saying what even should be this methodology for data science, for data teams, because I still don't believe that agile works for data science. I would say probably if you were to have to put a methodology to it, it would be something more like Kanban.
Yeah.
But something that you're structuring it, you're putting some time in there, but it can't be a sprint, in my opinion. But these are all things that we have to do as an industry of getting more mature. The problem is I don't see that we've actually put that maturity kind of cherry on top yet. There's still this people are even though there's been research and there's been a lot of stuff printed about it, people are still trying to figure it out for themselves rather than going back and saying, okay, what are other people saying?
I mean, definitely. And I think, is the old, this is the philosopher in me, but there's the old saying in philosophy of science that, if you want to fix, like when you analyze science and you try to be better at science, it's like fixing a boat while you're sailing. You know what I mean? There's no external perspective that you can take. There's nothing, you cannot go out of the boat and fix it from outside. You need to fix it while doing it. You know what I mean? Which gives you biases, but also gives you a lot of constraints because you cannot fix it all at once because the boat needs to be continuous sailing as you fix it. And I think in the sense, the data practitioning and the data words and all our work philosophies and approaches are sort of in the same boat. Terrible pun. It's like we're trying to be better at data science, data practices, definitely building a companies out of this. But we are doing it while inside of this shifting landscape, new tooling, new ideas, open format, S3, AI, LLM, new hiring trends. Now data science is the biggest, I think, master at Berkeley. I heard yesterday something like that. So like new educational stuff. And all of these things kind of like converge together in this mashup, and you need to do the best with what you can. And it's not very easy because there's no fixed point that you can use. There's no, again, external perspective. You're doing this while everything changes at the same time. So true, I think we should do a better job as an industry. And again, building tools at least to help with that. But on the other side, it's a very hard job. And if we think in the great scheme of things, 2016, the golden age of data scientists, 2034, is 8 years. It's like less than the time that I spent in school. like way less.
You talked about this company that you founded after that called Kuzu.
Yeah.
Why did you end up founding a company after that?
I always wanted to build my own company, and this goes back to my time in Diagramma in Italy. Like when I was managing projects and stuff. Like I always wanted to build a company. Kuzu, I always call it the best company that people will never heard of, because it was like this kind of tiny gem and weird company on so many dimensions and clumsy. But they've like some of the ideas and some of the things we built at Kuzu with 5 people is like still up to these days unmatched in the information retrieval world. I founded Kuzu with 2 friends, one Ciro and the other Mattia. They're both Italian, as you can guess by the names, and we met during university. So they're a bit older than me and less good looking and less funny, but they're sort of similar to me. And Ciro ended up doing neuroscience after studying, and then with me, and Mattia was doing decision theory and all that. So we have a bachelor in philosophy, all three of us, and then we kind of ramified in different parts of it. And then Ciro and myself started working on a way to do better search using natural language processing. Okay, remember, there's no transformers, no LLM. Like, it's 2015. The time is 2015, 2016, and the point was that keyword search at that time was the dominant way to search for things. And we said to each other, well, we understand language, we understand neuroscience, we understand how a human actually read. Can we build a better algorithm for people to not use keywords, but to search in a natural way? And so from that, the idea with Tuzo was born, and Mattia kind of joined us because Mattia, after PhD, was doing e-commerce tech. And so he knew a lot about e-commerce. And Mattia said, like, e-commerce search is a big problem. There's a lot of money to be made because everybody's searching on e-commerce. And if you make search better, people will pay you because of that. And so we kind of combined this technological idea, playing around with search algorithms, with this business idea of like e-commerce is a good vertical. And the fusion of this thing was Tuzo. We got our first money from Alchemist Accelerator. So what we did, we went on Forbes. It was the 10 list of accelerators. There was the golden age of accelerators, if you remember that. Now there's one left, which is Y Combinator. But at that time, everybody was trying to emulate that in some sense. And so we got the list of the 10 best accelerators. We applied to these 10 accelerators. We got in 2, and then we picked Alchemist, which was at the time the highest ranked for B2B company. So with 50K check from Alchemist total, we all moved and left our life. From New York to San Francisco was me. Ciro was in Belgium doing a postdoctoral fellowship in neuroscience, and Mattia was in Munich, Germany. So everybody left their life with 50K total in the bank. We got a house in the suburbs of San Francisco. Mattia literally lived in the garage, and we lived there together and worked together for the entire life of the company. So from the inceptions, which was, that day, to selling the company, 2.5 years later, we lived together, worked together, and kind of being like literally small brothers in arms in that sense. And these people are the same people that are building Bauplan. It's kind of like, once you be in the trenches, these are the same people that are building another company together. And building a company, especially in those conditions, just very different from the one we're building Bauplan with, was an heroic effort in many cases. It was not like the TechCrunch, headlines of like, random person lands in San Francisco and people throw you money. It was the opposite of like, oh my God, we're gonna pay rent the next month. And so Tuzo was this, again, incredible company. It was a mix of like completely we did because we didn't know any better, to incredible things that we didn't even realize how incredible it was even after the acquisition, if up until the acquisition happened. And then we got a bit more perspective on the world and say, oh, wait a sec, we solved this in pajamas. Like, why nobody else can solve this in the world? We solved this by eating ramen and doing something else. And that moment was kind of revelatory of like, we're very good at building stuff. We should be a bit better at promoting what we're building.
The entire time you're telling that story, did you ever watch Silicon Valley on HBO?
Of course. It was there while I was. It was on while I was there in the show. Exactly. Yeah.
Okay. And so, which one of you was which character?
I think we're a bit different than the Silicon Valley guys. So the Silicon Valley guys, so we're B2B people first. I think I'm the nerdiest one of the three. I'm the CTO and and kind of the founder. Mattia is definitely the one with most of the commercial sensitivity and kind of ability to empathize with people, which I think is very important when you sell things. Especially in the very beginning, when you sell your trust. You sell with your trust, in the sense that you kind of like need to convince people to try a product that nobody's ever tried. The hardest thing that there is. It's harder than building the product, which is also hard. And Ciro is a bit is kind of like a philosophical beard with the eyes. It looks like the wisdom. It's kind of has more wisdom than we have. He walks like an old Italian person with his hands behind the back, like he's like 82. Even if it's like whatever 42, whatever it is. and it's definitely the more reflective among us, and so it's like natural CEO in that sense. But it's very different than the Silicon Valley CEO, which was a huge tech nerd that kind of needs to learn how to kind of like communicate with people afterward. Ciro is a good scientist, but he's also a good people person in the first place. So that transition has been easier in that sense.
You also hit something that I've been dealing with, and that is, how do you find people who are good to found companies with, where it's like you're getting married, and in your case, you were actually living with them for 2 years, so you could have gotten married. Maybe it was a common law marriage. How do you deal with it, or how do you find these people that you could be so close with and actually create this without killing each other? My problem hasn't been the killing each other part. It's been finding somebody who's actually a decent person who will follow through.
I think, as people say, the first reason why startup fail is because co-founders don't get along or fight at some point, or they're not, they're like there are differences that cannot be reconciled anymore, or something like that. And I can totally see, like, I know a million other, like, by this time, very different time than Kuzu time, I'm a bit part of the ecosystem now. I know a lot of founders. I'm LLP in some funds. I advise companies and so on. And the answer is, like, I've seen. I haven't seen a recipe for this. I've seen unions that used to be, or I consider, like, completely unbreakable, unfold, after a few years, and then a likely founder to actually like each other for a long period of time. So unfortunately, I don't have much to contribute, if not to highlight my own luck into this, of finding people that are, decent people, morally decent people that are going to do the right thing. And they're going to stick with you through thick and thin. Again, my first company was, like, really punk. First company was incredible. It was like an incredible level of stupid optimism and kind of like, sheer resilience to basically adverse conditions. But also very talented, because at the end of the day, you want founders that figure out things by themselves. Like, I don't have time to explain how the product worked to Mattia. I mean, I'm exaggerating, but I'm assuming that even if it's a sales guy, he knows enough to pick it up and kind of do that. And and Mattia before Bauplan, Mattia didn't code. Now he codes a bit, because he wants to learn how the product works and so on. So I trust him to be able to learn hard things by himself, as he trusts me to not be an enterprise customer. But on the other side, we also get along, and I know that if when we get acquired or whatever, there are always tough decisions to be made as founders. Everybody sort of had this common trust, and in our case, I guess, genuine affection, that sort of is a boundary for everything else. So all of our discussions, even the unpleasant one, which God knows we had throughout the years, always happen within this space in which we know that at the end of the day, we trust each other and we want what's best for everybody. Which, again, is not a recipe. Is just stating out loud how lucky I've been to find Ciro and Mattia, and how incredible things can happen when you meet these people. The other thing that I'm to say is, we knew each other before. That's the only recipe that I've seen working more than chance in all these years in Silicon Valley. Is a lot of good founders that stay together and kind of build great things. In many cases, used to have a history before building a company. They didn't meet because of the company. They met before, and they found that a good way to do something together was to build a company, which it feels to me like a good way to minimize, or, well, still high, but minimize the risk of, like, as you said, killing each other or something like that. If you know something for a long time, before money was on the table, before shares were on the table, and they were already decent people, chances are they will stay decent people even when shares are on the table.
Okay. Yeah, I appreciate that. That trust, knowing them beforehand, that's really good advice. Thank you. So let's talk about Bauplan,
Sure.
and we will switch over. I need just a second to set that up. So we were about to do the whiteboarding part of this, and you mentioned that some of the questions I was asking was interesting because you were going back and thinking through things you hadn't thought about before. Tell me more about that.
Yeah, I mean, absolutely, and I really appreciate that. I was joking, like, being as a philosopher by training, I can talk mindlessly and ramble for hours without problem. But it's very fun and kind of like, I guess, self-revealing when you talk at length, like this podcast allows you to do, about these steps in your career and your life that kind of led you to where you are now, which is stuff that I haven't thought about, at least in a cohesive, organic way, in the way that your questions kind of like unravel that for a long time. I discussed things today with you that I haven't thought about for I don't know, 10 years or something like that. And I guess there's a bit of insight, the inside this 2020, whatever. But there's my trajectory, which is random and kind of unconventional by most standards, today feels a bit less so, thanks to your questions and somehow the way in which we went through things. And I really do feel that something that I seeded 10 years ago now is being fruits. So thanks so much for kind of like giving me back a part of my part of my youth in some sense. So happy about that.
Well, good. Yeah, and this is the call to other people who want to become guests, because this show is really different. It's not just let's just talk tech. It's let's talk about your career. Let's talk about how, in this case, what we're about to see when we talk about Bauplan is you made a trajectory that got you here. And I find that there's a very consistent, usually media narrative, um, that says all of a sudden Jacopo creates this company that gets acquired, and that isn't what happens. Even what you were talking about of creating these things that were really interesting, it was 2 years of work, and even behind that there was this part where you didn't really know everything about this, and yet you created it. And those sorts of narratives usually don't fit into what a PR person wants out there, but for this, they're really important that people know.
Yeah, and I appreciate the long form in some sense. What where people do 120 character or whatever they are. Like, I'm really not good at Twitter. I'm not a big fan, but I really appreciate people that still takes the time to discuss with other humans for a longer time, or whether it's synchronously like we're doing, or asynchronously to a long form content, right? I always get sometimes people's like, hey, your articles are too long or blogs are too long. Maybe that's one way of seeing that, but the other way of seeing that is that as long as they need to be to actually convey the narrative, the full story. And I feel this podcast is kind of the synchronous versions of that, of like, maybe this is a longer chat than the one that I used to, but it's what we need to do to kind of like get a 360 picture in some sense of things, and not just a tiny bite that you can upload on Twitter or whatever. So thanks to you for for creating this environment where people are able to be themselves a bit more, in a sense.
Well, thank you. So let's talk about Bauplan.
Sure.
And to start out with, would you mind whiteboarding out what Bauplan is?
Yes, let me do this whiteboard exercise with my newly found iPad and my newly found pen, so that everybody knows that if I make any mistakes, it's because of the setup. So Bauplan is the combination of two things right now. One, which is functions, okay? And you can have a function in SQL, or you can have a function in Python. Sorry, I have the worst possible way of writing in the history of humanity. Plus, we call it Git for data, which means that if you have your tables here, okay, you can create a branch. You can, I don't know, add a column here, and then you can merge it here. Okay, like you do with Git, and I'm sure we're gonna go into details to this. But Bauplan is the combination of these two things. What is the simplest possible compute model to do data work? Is a function. Function can be written in SQL, can be written in Python, but is a unit of compute that takes some table, that takes some data input and spits out some data output. Everybody knows what a function is. You may not know what Kubernetes is, you may not know what AKS is, you may know what Spark is, but everybody knows what a function is. And on the other side, what do you need to do proper data work? Proper data work should be done in production. Data cannot be tested, developed, debugged with toy dataset that you sync once every 3 months in your dev environment. You need to do it in production, which begs the questions, well, but I don't want to disrupt production, and that's where Git come in. When you work with your code, you work with your real code. You don't work with a toy code. You just work on feature branches so that you don't bother downstream people from the mistake you may make or the experiment you do. Git for data is the same concept, but for data. You work with real data, it's production data, but you work on your branches so that downstream systems are not affected until you believe that the system is stable enough to be promoted to main. The combination of these two things, we believe, are 95% of the story of how you work with data on object storage in 2025. And our philosophical stance that we're going to fight everybody or every concept that is more complex than this one, because we really do believe that you don't need it.
Yeah, as you're talking about it, I think I've bumped into people saying that they were doing this, not as a product, but more they were trying to do it somehow with some hacked together code. But definitely this is interesting because you're right. How do we get things? So what I like about this is there's a simple model. Our programming model needs to be as simple as possible. And our way of working with the data needs to be as simple as possible. But probably the first question I have is this branch materialized?
So the branch are copy and write. So what actually happens in an example like this, that the source table will, when you create a branch, the branch is a zero copy clone of your entire data lake. So it's a no op. It takes a fraction of a second. And then the typical data pipelines is you start with a source table. Say you start with, table 1, then you apply some code, and then you produce a second table here. I have raw data and I need to clean it for a machine learning model, right? Typical data pipeline, okay? And so what happens in the branch is that table 1, which is the source table, doesn't get copied in any way. The source table is the same physical file backing it across branches, but you just have a pointers in the catalog that signals that you are in branch feature. The second table, which is the one that you're actually writing with your code, that you're materializing with your code, is different than the one you have in main, and that's actually gets written. But when you go into the merge process, things go back. So when you merge, does this table get written? No. Again, there's a simple pointers that changes in the catalog that make this basically zero copy. So the system tries to, as much as it can, we can go into the details when we cannot do it yet, try to not copy data in a sense, but to just basically shuffle pointers in the catalog to the underlying physical representation of the system. That's why it's relatively cheap to create as many branches you want. And this allows the flexibility to developer using Bauplan today to experiment and write more code, not less code, because you're not afraid. We remove the fear of making a mistake in your data lake because A, you can always delete your branch, and B, you have point in time commits. So it doesn't matter where you are in this two-dimensional universe, where dimension number 1 is time. Oh, sorry, wrong thing. Dimension number 1 is, oh my God. Dimension number 1 is time, okay? But at any given point in time, a table can have different versions, which are the branches. So this two-dimensional universe in which Bauplan kind of like embeds all your data work is fully traversable through the API that we give you. So you can move from here and get back here, but you can also move from here and get back to 2 weeks ago, which gives you the peace of mind that no change is ever permanent, which we believe is a great kind of mental model for people working with data compared to the standards kind of like, oh my God, what if I copy this and I destroy the table type of thing?
That is interesting because now we're getting more to what we did with databases. For example, people are not as worried about making, I mean, you obviously shouldn't be changing your database all the time, but adding a field, adding a column in your database is not the end of the world. It's not. But when you're in data, when you're at large data scales, adding these fields, changing these fields is often a major problem. And so a lot of the friction that you're actually happening is because of that. So just to make sure I understood, so let's say you had a table right here, and
Yep.
you make a change. You're adding a new computed column, and you're computing that out here.
Yep.
This is an in-memory change, but you could persist that out to disk if you so desired.
Exactly. So Bauplan, so the Bauplan function model is, let me delete
Here,
it.
one thing I forgot to point out is you see at the top there's arrows. We can go on to whiteboard 2, and now you've got a new whiteboard.
Oh, okay. Let me see. Oh, awesome. Thank you. So Bauplan functions. So if you take a function here, okay, Bauplan function receives as input one or more tables, okay, and spits out one table. Okay, that's a basic programming model. Inside the function, you can write whatever freaking Python code you want. You can import packages. We can go into how we do all the magic of that. But inside of here, that's your job as a developer. Your job. And everything outside the function, making the function running, ever the environment ready, bringing you the data from the tables that you need as input, and moving the data out as output, that's our job as part of the platform. When you both tables in input, so this ones, and the one in output, this ones, can be in memory, can be ephemeral tables. And the ephemeral format that we use as a common lingua franca between all the runtimes is arrow, which I'm sure you met in other podcasts as well, but we can talk about that. And so they can be in memory, or they can be stored. They can be materialized in your object storage. So this, and this can be read or written to S3. The format we use at rest, the format we use as a storage system, is called Apache Iceberg, which is a popular open format for interoperability and table semantics over S3. So every time you can decide if you want to persist your changes, or if you just want to compute them and perhaps send them to your terminal just to see how it works. Bauplan has a very convenient function called dry run. So when you run things in Bauplan, you can add a flag, and that flag basically doesn't persist anything, but kind of gets you the feeling that if all your code, all your expectation, all your data flows correctly, and then you can decide to materialize it after that.
Okay, that's interesting because a lot of times you're trying to do all that yourself. The Sparks and that sort of thing, they don't have this concept of a dry run, even though you need it. If you're doing this for real, you need these concepts of dry runs. You need these concepts of going back and redoing something from scratch.
Yes, and you want to make sure before you do anything, you want to make sure that you can get a very fast turnaround, very fast feedback loop before you actually do the thing. Like Bauplan is incredibly fast to build and to run. Again, containers takes 100 milliseconds to build. Data fly between function in arrow. Like everything is built for you to have the same feeling that you have developing local, but with hundreds of millions of rows, which is the normal software engineering flow, which is very different from big data, kind of like more feature heavy enterprise features with notebook clusters. You have to wait for the cluster, blah blah blah. So Bauplan is kind of the opposite side of the spectrum compared to this traditional system, which makes it good and bad for different use cases. But it's really a different way of kind of like conceptualizing the life cycle of data.
You point out something that's important, and that is that life cycle, but the timing of the life cycle. I don't think that teams really think about that as you create a flywheel of how long things take. If you have a bunch of friction at each point where this takes a few minutes, and then this takes a few minutes, and this takes a few minutes, each one of those it's not just that there's it takes 10 minutes for the job to spin up or an hour for you to get results. It's that the person is waiting on that. So the number of times or the amount of time in their day that they're spending spinning that is time that they can't be productive. So if you can reduce the amount of time in those, now your flywheel becomes even faster. And that's a key concept. I would encourage everybody to think, how do they do?
I think there are two dimensions of cost when you think about this type of systems. One is the development productivity cost in terms of like how much I'm waiting for the system to be ready for me, in a sense. And Bauplan tries to minimize that across several dimensions. To make an example, if you think about functions and building functions in the cloud, the easiest way for you to do this is AWS Lambda, the most famous fast system that exists. Rebuilding a container, rebuilding a function in AWS Lambda is 15 times slower than Bauplan, which tells you, again, like how important it is to not kind of like, have all this interruption flow. But that's one dimension of cost. Another important dimension of cost is cognitive complexity, as in how many new concepts, how many new abstractions, how much does it take for me to think about what the system is doing while it's operating? And this is where I think the distance between working with Bauplan and working with standard, more, let's say, I don't know to say, like more bulky platform, based on big data system and so on. It's kind of radical departure. Like Bauplan cognitive overhead is almost nothing. You can learn Bauplan in 30 minutes as a fresh out of school undergrad. We actually have examples of that. While it will take you 6 months to figure out how to use PySpark properly, even if you're very good at it. And I know because I did it. So I think there are always two costs that people sometimes, people are like, hey, developer activity is very important, true, and feedback loop. But on the other side is like developer ramp up is as important, especially in large organization. You want people to learn a new system in days, and definitely not in months. And so Bauplan has been built with that in mind. And that's why, as you mentioned, the compute model is the simplest possible. It's a freaking function that everybody knows what is.
Well, you mentioned another key part of the functions, and that is the Python packaging.
Yeah.
I have two bones to pick with Python. One is its typing system is pretty terrible. I hate it. And the other big one is the packaging system coming from a Java world is terrible. How are you dealing with that?
So both are very, very good complaints, and then definitely we can relate to that. So what happens when you build, sorry. I need to really step up my Jotboard game. So def my function, and this is going to be my body, and this is going to be return my data frame or whatever I'm using. So this is the basic of any function, taking data as input and returning other data as output. How does Bauplan add the environment information? We subscribe to the everything as code philosophy. So your environment is specified within the function. So you're going to do a decorator here. It's going to be Bauplan. And you're going to say in these decorators that I want pandas 2.2.0 or whatever, which means that every function is this atomic universe, which is completely isolated from the process point of view. If you have 4 functions in a DAG, we can see how we chain them. But you can have 4 different versions of Pythons or 4 different versions of pandas in each one of them, and nothing will happen. But this communicates the data. So it's air-gapped as of processes. It's fully containerized and isolated for reproducibility. But of course, there's a way for you to pass data between the functions, which is what is different than using, for example, a set of lambdas that you need to somehow connect yourself. So this is the experience from the developer point of view. What happens when we actually take this pandas declarative thing? The user wants pandas. What do we do? How do we make it work in a way that this goes inside this function? Okay. And the way in which we do this is that we take a request, which is pandas 2.2.0, and then we have a service that returns all the set of dependencies that make up this. So it's package 1 package
when you switch whiteboards, you have to let me know.
Sorry about this. Okay.
All right, go ahead. Sorry.
No worries. And so you have. Let's start again. So when you take pandas, which is the request of the users, I want pandas 2.2 for this function. We have a service that returns all the packages that actually will be basically the transitive graph of all the packages that builds up pandas and the packages that builds up the packages that builds up pandas. Okay, so we actually get the full list of these things, which now forms a deterministic snapshot of the type of environment that you need on our final system to make sure that when you do import pandas, this will actually work. So this is the planning part. And then this gets sent to the machines that actually run your code. And they say, hey, you need to have installed these 3 packages to make sure that the function can run. And what the system does is going to check its package caches, which all the packages are there, all neated and orderly sent. And you're going to say, oh, I have 1, I have 2, but I have 3. So I'm going to download 3 from the internet. And now that I have the 3 packages, I'm going to build a container for my functions. And that's a trick. I'm going to mount these packages dynamically while I build the container to build my Python environment. And so the function will basically get in 100 milliseconds, because now building a container is just basically mounting part of your file system. And it's going to have the dependency that you have in a deterministic way that is reproducible, from here until the end of time. This gets you way faster build than doing the normal container stuff that people do, build the requirements or whatever. And it gets you a lot of reusability because it exploits a fundamental fact that we call team locality, in analogy with space locality and time locality in CPU. What is team locality? People working on the same dataset or similar dataset use most of the same freaking packages. And even when they use the same packages, the transitive dependencies of pandas 0.2.2 versus panda 1.3 will still comprise most of the same underlying packages, like NumPy, for example. Which means that if you're clever with caches, you can actually build environments very fast in a way that basically makes the experience almost instantaneous for the vast majority of use cases. So the trick is, don't install packages in container. The trick is, install packages as part of your file system and build them statelessly as read-only folder while you actually build your container. We have a long blog post for people that are interested that shows this more in detail, but that's a fundamental trick, which goes back to a paper by the University of Madison, Wisconsin, by Tyler Arter, which is one of our professor research contractor and advisor, and other people. And we didn't even find it implemented much until we figured it out and found it again. And that has been very good. It's been very good because of the problem that you mentioned. Package management gets abstracted away like super well. And B, the feedback loop is almost instant, because when you download stuff, it's an EC2 with unlimited bandwidth that downloads stuff. And the vast majority of cases, you're not downloading stuff. You're just using something that your colleagues have already done.
Yeah, that is interesting. As much as people watching this may not understand why this is so important, this whole import system, this is always the Achilles heel of these systems. I know because I've dealt with a lot of them, and that's one of the first questions you ask. How do you deal with the packages? How do you deal with different versions? What you'll usually get is, we support Pandas version X, and you're on Pandas version Y. And so you either move or you say, and then the other part is very interesting. I haven't heard of that, of doing these mounts this way, speeding this up. That's really interesting. One thing we haven't covered is, or you mentioned it briefly, is that the interface for doing a small file is as being distributed. Could you draw out the distribution? Go to a screen 4, to whiteboard 4, and draw that out, please.
Yeah, I'm here. So you want to see how this file that people write gets actually executed in the system. Is that correct?
Well, it would be, so how do we go from we're testing on our laptop, and now we're going to do this on the cluster. And what does that cluster look like, and how does that cluster execute?
Perfect. So the first thing that we need to dispel is that there's a concept of a laptop in Bauplan. So the laptop is helpful for you to write your code, but nothing, and I cannot be more more explicit, nothing ever runs on your laptop. One of the pain point of data science project going to production because of the package freaking system that Python has is it works on my computer. Everybody knows what the it works on my computer problem is because everybody in their life, I think, found that. In Bauplan, the problem is solved because nothing works on your computer in the first place. Okay, so remember when I said you need to develop with production data like directly, but safely? The same concept applies to compute. All our function, all our code is always executed in the cloud. It just so happens that it executes ephemerally. So again, nothing ever persists if you don't want it to be. And things are like safely sandboxed in the sense that you can write stuff to branches to avoid problems. So what happens? You have your laptop. How do I design a laptop? It is a laptop. This is a laptop.
It's a good thing you're labeling that.
yeah. So sorry about this. Like, there's a running joke in the entire company about how bad I am with pens. But yeah, if you can do a better laptop, you can do a better laptop. I'm happy with it. So the laptop contains your.
It's so bad. I'm going to have to for the first time in the history of the show. I'm having to draw out a laptop.
Okay, that's much better. Laptop. Thank you. This is a laptop, and the laptop is your code, like the function that we said before. You can have one, you can have a multiple if it's typically a pipeline. What's the difference between one and multiple is that you just chain a function together. That a function becomes the parent of another function. But the mental model that you have is the same. So your code gets shipped to the control plane. Okay. And the first thing that happens is we out. So are you the people that, the person that said that you are? And then we take your code, okay, and we go to a place called code intelligence, which is our model that takes your code, parse it out, understand the decorator that we mentioned, which pandas we need to do, which tables are you referring, is this table that you're referring exist or not? So the system is kind of in between a database and a runtime because it will do things that database will do. For example, check your data types and making sure your tables exist, your column exists, your filters can actually be pushed down. But it will also provide you a full runtime for arbitrary packages, like for example, pandas or NumPy and so on. We call it the logical plane in analogy to what happens to a database. So the logical plane is what the user tells you in a file, structured as a graph, structured in a way that is not a file, but is actually something we can make inference on. Fun fact, for audience of the show, the graph is actually hosted in ephemeral Kuzu graphs. And I'm sure you remember the episode with Sammy. So we were one of the first customer of Kuzu. And we use Kuzu in production like every day, tens of thousands of times, because it's part of our inference layer. So from the logical plan, we get a physical plan. How do you say physical in English? Physical plan? Which is, again, in analogy with a database, is filling the gap between what the user wants to do and what needs to happen in the actual runners to execute the function. What do I mean by that? The logical plan will check that your input table exists, but it won't tell you where the input table is. Meaning it won't tell you which part of your S3 buckets correspond to the actual files that you need to go and read for this branch, for this point in time, for this table. And that's part of the physical plan. So the physical plan basically fills in the gap and produces a full recipe, like something that from the top to the end tells you what you need to do to run this DAG. What function depends on which function, which containers you need to build, and so on and so forth. Okay, that physical plan is then sent to the runners. And I put here a nice dotted line to showcase the difference between the control plane, which is multi-tenant and doesn't see any data, okay, versus the data plane, which is single tenants, see your data, is privately linked with your S3 buckets, and we don't see it. Okay, so you have an S3 bucket here. Okay, and this is paired with your EC2s. Okay, and only you, only your team, just you can access EC2. So what happens inside each of these EC2s? EC2s receive a plan, and then it will use our purpose-built function runtime to execute the function one after the other. So it's gonna get the instructions. Hey, get this Parquet file, and you know what it's gonna do? It's gonna do the same thing we say, but for code. It's gonna check if the Parquet file is already cached. If not, it's gonna retrieve it. It's gonna produce an arrow table out of this, and it's gonna feed it to the function. It's gonna run the function with the container that we built from your packages, and then it's gonna take the result of that function and gonna pass it to the child function, and so on and so forth. While this happens, and then we pause here because I think this is a good moment to pause. While this happens, there's a gRPC connection that will spit out real-time print statements or whatever logs and so on from the runners to your laptop. The end result is that when you do Bauplan run, the system will look like it's local because it's so fast and print statement happen like you were printing stuff in your terminal, but everything is remote. And again, we go back to the combination of two ideas. Productivity, you want things to be fast and snappy, and you don't want to go to CloudWatch, wait 5 minutes, and then click on things to understand what your Lambda is doing. You want things to print like it's a machine, but you want this to be reliable. So you would want this to be your machine because your machine cannot be a production system, while the runtime fully containerized is. And so Bauplan kind of tries to say that development, productivity, and production is a false dichotomy. You can be productive and fast when you develop and still be very reliable with the same exact system when you put it on a schedule or something. As a moment to pause to see, does this mental model make sense of what happens inside of a Bauplan execution where all the magic happens and the function gets actually run?
No, it completely does. And that other part that you were talking about with the getting the debug output quickly, I don't think people, unless you've ever dealt with this, you don't know how big of a pain it is to wait 5 minutes for something to actually show up on your logging. So you're either faced with bringing the log back all the time, downloading a file, or if you can get those print statements much faster, then you can iterate faster. So it's great that you're thinking about the speed of iteration being a key part of this.
Yeah, and the caching, both the data caching and the package caching speed up, again, significantly, as you can imagine. We can discuss about data caching in more details, but a very key point that everybody can just understand is this one. If you do this, so if the connection between data at rest and function is within AWS, this is 50 gigabits bandwidth, which means that if you do stuff locally, so if you do this instead, it doesn't matter how clever you are. It doesn't matter how good your laptop is. It doesn't matter if you're Jeff Dean. This thing here is going to kill you. You cannot beat the advantage of having data speed within data centers. And there's no way you can build the same experience if you actually develop local, which is another huge part of our value prop. Is developing local is not easy for production, but it also will slow you down because data is big. Downloading 100 million rows every time will just kill you. You can't beat AWS bandwidth. You can be clever. You can be cleverer than me in many ways, but you can't be AWS bandwidth. And the system is built for you to leverage this AWS bandwidth every single freaking time.
So you mentioned AWS. I assume you support the other clouds as well.
Yeah. So sorry, yes, AWS is also like a figure of speech, but the control plane is actually hosted in AWS and it's going to be multi-tenant, and it's us. But again, you never see this. This is not something you see. It's just what process your calls. But while your data plane here can be in any cloud, most of our initial customers are on AWS for historical reason. But remember, the only thing we need is a virtual machine in which we inject our binaries. Super easy. Every cloud supports virtual machines. And the virtual machine needs to be paired with your bucket or blob storage or whatever. So the data is in your storage. It never leaves. We subscribe to the lakehouse philosophy. Data is yours, is ever going to be. We don't want to lock you in with data. You don't have to send us data. You don't have to migrate. You can start with Bauplan in an afternoon, okay? Because this is permanent. Data is permanent and is yours. This is ephemeral. Our compute by design is ephemeral. Our functions get literally built as you need them because they're so fast, which simplifies a lot of the state management and all of that. And the additional benefit is you can destroy this at any point in time and nothing will happen to this. Like,
so you could use spot instances or some of the more ephemeral instances where they just go away, and so you could run it cheaply.
If you want to. Most of our customers actually opted out to to get a longer, like you get a longer lease, so you get always good machines and blah blah blah. But there's no technological reason for that to be better or less than other. It just so happens that for business reason we ended up with this. But the system is compatible with any sort of compute capacity in that sense. And again, I can't stress this enough. Worst case, this gets destroyed by a god. Worst case, you have to rerun stuff. But everything happens in a branch, remember? So even if things get muddled in between a pipeline, your production data is not going to be affected. I can't stress this enough. The system is designed for compute to be literally disposable and just rerunnable if you need it to be.
How dynamic is the spin up right here? Spin up, spin down.
So right now, most of our customers starts with one runner, which is what hosts most of the capacity when they do. And then we have spillover for burst capacity to more than one. That doesn't happen super often, to be honest, because of a counterintuitive fact that some people before us find out, but I'm not sure is super well known, which is as follows: that once you have a bit of capacity to serve pipelines or queries, it's very unlikely that in any given moment of time, all your functions will actually use the entire capacity that you have, which is why it's very inefficient to have a Spark job or a Spark cluster per job or per development, because it's the only way you can isolate processes in that particular sense. But you're going to end up with underutilizing most of your clusters and machine anyway. So what we do is that we actually try to be very good with bin packing your workloads in a way that we very rarely have to multiply machines, if that happens. From the point of view of the abstraction, people write functions. So the fact that the function is run here or here, it doesn't matter to them. All of this is by design part of the platform. But practically, as a trade secret, most people will use proficiently one machine most of the time.
Well, it's even deeper than that. As you mentioned RPCs, the more that you're making RPC calls, now you have I/O wait time. You have network I/O wait time.
Yeah.
And that's very inefficient. So the more you can keep things on a single machine, the better off you will be.
That's correct. There's a few other tricks there that are due to our choice of arrow as intermediate frame. So when you are within machine, arrow allows you zero copy data between parents and children. So can I move to a new one?
Yeah, go ahead.
Let me move. So when you think about the function, and the function spits out a table, is a pipeline. So let's say that there's a second function, f1, f prime, that takes this as input. Okay. The naive thing, let's say you do on lambdas, there's no way for this function to share this table. This table may be 100 million rows. Okay. There's no way for you to share it. You need to build something through object storage, or imagine you're doing an orchestrator. You can't do this with XCOM in Airflow. I mean, you can, but it's obviously not very nice. What we do is that this is arrow. So what you do is that you can have multiple functions here that reads off of this. This is a complex DAG. And this is fed as zero copy in all of this, which means that instead of having 3 copies of 100 million rows, we're going to get only one, which is the one that you write, which gets shared to all the other children. This is very effective, not just instantaneous, so there's no I/O, there's no span, but it's also very effective from the memory consumption point of view, which allows you, in terms, to squeeze more stuff into one worker and keep things faster. If things are faster, you can get, more capacity and blah, blah, blah. So this is kind of a flywheel of like efficiency that give you more capacity per minute because you're just better at serving this request. So Arrow is very good. Even when you need to go across machines, so this is machine 1, and you need to send the output of this to another machine. Again, all of this is Arrow. So this is called Arrow flight. So we're not going to pay serialization price here, and we're not going to pay deserialization price here because Arrow is the same in memory and over the wire, which is very different than traditional, JDBC type of like Postgres style of stuff, which means that, sure, this is not as fast as a zero copy within machine, but this is actually incredibly fast. If you benchmark it, we publish some small benchmark it, is moving 10 gigabytes between two machines with Arrow flight, Arrow in, Arrow out, is as fast as reading the same data from a local SSD Parquet file in the machine, just to tell you how fast it is. Because Parquet to Arrow, you pay the serialization, while over the wire, you pay the network, but you don't pay the serialization, which may be a huge overhead over hundreds of millions of rows. So in both cases, it's actually faster than you think if you design the system, in a way to leverage these technologies.
That's interesting. I've talked about it on the show, but that whole serialization, deserialization, what people may not understand is your CPU time is used. Let's say you're doing a worst case scenario, something like JSON. Your CPU is taking that binary data, changing it to an object, then making it into characters, and then sending it over. That those characters are rendered, parsed. That's a lot of CPU overhead. But what he's saying is that you're just sending bytes over here that are then mapped into memory back again.
Yeah, and it's just been a very good design choice from the early days. Like the system was built on Arrow since basically day one. One of the inventors of Arrow, Wes McKinney, is one of our investor, and that choice has paid off. Now the Arrow ecosystem is even bigger 2 years later. When we started with this thing, it was a bit more niche, but the zero copy kind of like efficiency Arrow features has been massively important for making the design as simple as, elegant as it is.
Yes, I know Wes as well. We used to work together at Cloudera.
Oh, awesome. Wes, also Chang? The other creator of pandas. Like Chang is the creator now of LansDB, which is a vector format for object storage. So is also a good friend and an investor. And he was, these people we're very happy with Bauplan because our set of investor advisors and research folks have had a huge impact on how we design the system. And it's been very inspirational to work with them and sort of like that our secret weapon to be such a small company that builds so much so quickly is because we can tap into this distributed brain of incredible smart people and kind of like, help us make the good choices.
That is another good point. I don't think people realize that as well, is when you're a small company doing this much code, either one of two things is happening. You've spent 3 years developing this, or you're leveraging open source well. And it looks like you're doing a little bit of both, but leveraging open source really well.
We call it the spare parts philosophy. As in, our first white paper was called "Building a Lakehouse Out of Spare Parts," which is kind of self-deprecating, but is also, I think, also clever in the sense of like a lakehouse is a gigantic surface of product to cover. The existing lakehouse that you may have heard of are like companies that are worth, tens of billions of dollars, and they're like tens of thousands of people. How do you do that with 6 people? How do you do when you're like a tiny company? And a way in which you can do that is by leveraging good open source project and sort of sometimes modify them slightly or sometimes just abstract them better than what they are out in the wild so that you don't have to rebuild all this lakehouse. That's a false dichotomy. You can build a lakehouse by building 20% of it, which in our case was the runtime, the magic that I explained before. That's all built by us. But many other things like Arrow, Iceberg, all of that, we got them from the community. And our job there is not a tech job per se, it's a product job. How do we make these things invisible to the user? The user doesn't know that we use Arrow. I mean, it's not a secret, but there's no need for them to know. The user just see tables. And I think there's been a huge underrated work in companies sometimes in API and abstraction design for the reason that I mentioned before. Like cognitive overload is a huge cost for adopting new system. And I think, if I can say so, Bauplan has done a fantastic job, even if it's not shiny as a paper, in actually giving you this API design that is so easy to learn, that abstracts away all of this. And I think a reason why Bauplan has been adopted virally inside of the companies that runs it, like, you start one day with 2 people and 10 weeks later there's 10 people using it, is because of the API design. It's not because of the tech per se. So the tech works and it's awesome and whatever, but it's because these things, of all this, people that use Bauplan see exactly 0. Like the best tech is the tech that people don't see. And I will die on that hill in that sense.
Well, yes, you're completely right, because one of two things happens: is either you expose it, or usually what companies will do is they'll write equivalent of a Bauplan to abstract out and hide a bunch of that complexity, and that is then running on top of Spark or something. So better to use something that's doing that for you. So let us. That was a great explanation. Thank you. So
Thanks,
now
Drew.
I have one question for you. As I was going through your LinkedIn profile and your experience, the question that popped up in my mind is: you have a background in NLP, you have a background in AI. Why aren't you doing an AI company with all that experience, and you're doing a data company instead?
That's a very good question. I've been asked many times by VCs, this time around where we're fundraising, and at that time I used to say, because when crypto people comes into your field, it's better to change field, but that was obviously a joke. When we built our first company, we realized that the vast majority of the time for us was not spending on the AI part, on the modeling part, the machine learning. That was 5% maybe. 95% was getting the freaking data into the good shape of what it is. And so we became passionate. We asked ourselves, why don't we solve our biggest problem this time? Like the 95%. Why don't we build the system where we wanted to exist when we had to do data pipelines, AI jobs, day in and day out, instead of the, EMR, Airflow, whatever things we were forced to do because there was nothing better at that time. And so that's how it was born. So that's definitely one characteristic. The second one, which it may have been true when we started Bauplan, I'm not sure what's going to be true in 3-4 years from now, is that we felt that the data market was very, very big. It definitely is. And so it was very suitable to support a more ambitious company than our previous one, in some sense. While the machine learning AI as a service market, again, we can discuss again in 3 years, but we felt it wasn't, in the sense as big. And if I try and see what people are doing now in AI, it seems that some people are making a lot of money, making very good businesses, but then there's a very, very long tail of companies that are actually struggling to convert the hype into actual things.
What do you think is something uniquely Italian that every American should try?
You mean as a food, or like as an experience, or like, what do you mean?
Anything. Italians. The first time I went to Italy, I knew a lot about history, but I didn't realize some of the other parts. The quintessential tourist things, limoncello, for example.
Okay.
But there's also the lemons of Sardinia, or there's all these things that you may not know as an American because it doesn't make it into a movie or something like that.
That's a good point. So yeah, okay. So things that you want to try, but they're not like they're not like mainstream. That's the point.
Yes.
So I mean, as I said before, if you like food, so if you like food, almost any place in the world will have something that is like, the place in Italy will have something that is like uniquely good and different. Like next to where we are, where I am today. For example, there's a type of cured meat called capocollo di Martina Franca, Martina Franca is the place where it does the village 3 kilometers from here, 5 kilometers from here, and it's a very, very incredible alternative to I don't know, prosciutto or something. So you can have it on a bruschetta. You can have it with bread. You can have it as as an appetizer, and it's like amazing. And that's a very, very specific thing of here. I don't think they export it. So again, just on top of my head of something like around me. If you think about things that I really love that are not from here, but there are still things that are amazing, maybe a bit more mainstream, but like from Sicily, which is my favorite region for many dimensions, I think you should try cannoli. If you never tried cannoli, ricotta cannoli are amazing. And the other thing you should try is granita, which a person in New York one time described to me as a slushy, and I found it profoundly insulting. But that person didn't know I was Italian, so she was trying to be helpful. And it's like, if you don't know what a granita is, imagine it's like, no, I actually know very well what granita is. And granita is also, originally from Catania, if I'm not mistaken, so from Sicily as well. So these are like tiny things that you do, but wherever you go, you're gonna find a million of them. Like ventricini. If you like cured meat, we have like 25,000 of them. If you like cheese, I'm allergic to cheese, so I cannot give you a recommendation. But I still find the same variety of things that are not things that you eat. What I would recommend, and they're not obvious historical stuff that you need to go and see, like Castle X or Roman Fort Y. One thing I would suggest you to do is to pick a random Italian tradition, or part like town celebration, town party, because we have a few of them, and they are very weird in a sense that Americans ones are never. Sometimes they're very cruel, like the Palio in Siena, when there's like these horses that they go around in a very tiny square, and the entire city fight, of over that, all the neighbors against each other, and there's been there since the Middle Age. But there's a bunch of this historical recurrence that has been there for timeless time, that to the modern eye they look, I don't know, to some extent violent, a bit gross, some more, but they're kind of raw and capture the spirit of some places. Another example that would sound incomprehensible, I guess, for American is for Carnival. There's one city in Italy where people throw each other oranges, like full grown oranges. So there's like cart. There are people on a cart with a kind of like the equivalent of an hockey, the hockey goalkeeper mask, and they will throw oranges down as they travel to the city to people in the city. The people in the city will collect the oranges and will throw them up and eat the people in the cart. And that goes on for a day. I may not necessarily suggest you to take part in the throwing because, every year somebody lose an eye or something. But again, this is a very weird way in which a town and a community comes together. And I think in Europe, in Spain is also famous for this stuff. Like in Europe, this is somehow what still happens, and it's typically something that has been happening for a long time. I haven't found the equivalent in North America, or not to the same sense of raw and, even kind of like, I don't know, violent connections with each other, so to speak. So that's a very Italian thing. So I would suggest you to go and see one of them, not to participate, to get the feeling of like how these tiny communities still come together with fierce and and competition and violence, but at the end of the day, it's a party. So at the end of the day, this is a great event for the city, and everybody's happy to be part of it. But I don't know if any of them makes any sense to begin with. To an American, suggest you need to help me to see if I actually paint a picture that makes any sense.
I think it would be for adventurous Americans or Americans who've been there, or they've been there a few times, or they've been there for a bit and they want to go off the beaten path. And I haven't done the ones in Italy. I did one in Malta. It was called Bari Fest. Okay. Very similar thing. It's the entire village gets together. It's a big village party. And I think you're right. I've never seen the equivalent in the US. And I'm obviously originally from the US. There's no, hey, everybody in the town gets together and they have a party. I even went to Albi, France, and there were similar things where here's virtually the entire village population all turned out and eating there together and having fun. And it's a uniquely communal thing, but it's also quite nice. And you get to try all kinds of different food and meet the locals in a different way than I think you normally would in the US.
Yeah, like I think it's different style. But yeah, I think a unique thing about Italy is that the region you go, they're gonna have their own variety of this. Again, there's not one thing that is like, oh my, yeah, Siena is very famous and probably is internationally famous in some sense for people that are a bit more, a bit more in the known about Italy. But there's a million of other events like this with different flavored, that varies across different dimensions. And you can spend your lifetime in the country, which, I spent half my life here, and there's still many of them that I just know of, but I never seen, and probably I will never see. Which is, it's kind of like, like New York, like, I don't know, you can live in New York your entire life, but you never know New York in some sense. And Italy is in for this type of cultural thing, or as you're saying, cuisine or history, it's kind of like this. They're just too much for a human to explore. So sometimes, it's a design space that is just fun to, you go, you get lost in it. You're going to explore some part of this landscape, in not this part of the decision tree, but, it is what it is. And at the end of the day, you just get the most out of it.
And I was thinking of Birgerfest, not Birgerfest. It's the places, the Birgu in Malta. But there's another part that I would suggest to people is that a lot of these festivals are temporal, or foods are temporal, where they aren't as much in the US. So in the US, you don't have, here's this thing that you pretty much only do in one part of the year. I guess Thanksgiving, eating turkey is the one time people eat turkey a year.
Yeah.
But in Europe, there's a lot more. You eat panettone in Christmas, and you eat this or the king's cake is this time. And so if you don't go around that time, you'll miss that thing. So yeah, definitely check out what are other times of the year, not just for a festival, but foods that are different. Or in Mexico, you have tamales. Tamales are usually a Christmas thing, where in the US, you eat them all the time, and I would.
Yeah, I think there's like a coupling between some of these cultural layers of our society's structure, like the competition, the parties, the food, the religion, which are, you would say vertically integrated in many Italian villages, whatever. I think in the US sometimes you get the decoupled version. Like you kind of abstract away one thing, panettone, and then you can sell panettone every part of the year, because you sort of don't get the vertical integration. You just get this particular thing, which is now abstracted away in a modular system. So you kind of lose the context. It retains the flavor in the sense of panettone, but it kind of lose the context for which to an Italian would be incomprehensible. Like if you go to an Italian and say, I ate panettone in March, they would say, what is wrong with you? Or something like that. You know what I mean? So I think that's an interesting, different way of like kind of slicing your human experience in different layers, so to speak.
Jacopo, thank you so much for coming on the show. You set the record for most gesticulation and hand gestures in anybody.
Thank you. That doesn't surprise me in the slightest. But thanks so much for having me. It was a pleasure, really a pleasure to chat. And thanks again for everybody to listen to all of me rambling. If you want to chat more about any of this topic whatsoever, you know where to find me. I'm very easy to find through LinkedIn or online, and I'm super happy always to chat with people. I'm very easy to reach in some sense.
Thank you.
Thank you.